Hi students, today we can study the instruction set of 8085. Before going into the instruction set of 8085, we can see what is an instruction. An instruction is a command given to the computer to perform a specified operation on any given data. For example, add B. It is used for adding the contents of register B to accumulator or register A and the result is placed in the accumulator. The 8085 instructions are classified into 5: data transfer group, arithmetic group, logical group, branch control group, and lastly IO and machine control group. First we can see the data transfer group. The data transfer group of instructions are used for transferring the data from source to destination. And the source and destination can be either register, memory location, etc. In data transfer group of instruction, the data from the source is copied to destination without changing the contents of the source. It is equivalent to copy paste in Windows. Examples for data transfer group are MOV, which means move. Move A, B is a complete instruction. It is used for transferring the content of register B to register A. Then MVI, move immediate. The data is specified after this opcode. MVI and MOV are operation codes. As you know, an instruction consists of two parts, opcode and operand. This MOV, MVI, LXA all are opcodes. LDA is load accumulator with the content of a specified memory location. LDA will be followed by an address which is a 16-bit address. Then STA 16-bit address. Store the content of the accumulator in the specified memory location. Next category is arithmetic group. It is used for performing different arithmetic operations like addition, subtraction, increment, decrement, etc. For example, ADD used for adding, addition instruction. This add B which is used for adding the content of register B with accumulator and the result will be placed in the accumulator. SUB subtract instruction, INR increment, DCR decrement. Next category is logical group. It is used for performing different logic operations like AND, OR, NOT, compare, rotate, etc. For example, ANA followed by a register and the content of accumulator with a register, or it can be a memory location. Then XOR exclusive OR accumulator. If the accumulator content is exclusive OR with the accumulator content itself, then the accumulator content will be 0. And it is equivalent to the instruction MVI A, 00. CMP means compare. RAR means rotate the accumulator right. Branch control group. These instructions can be either conditional branch instruction or unconditional branch instruction, subroutine call and return, restart, etc. For example, JMP. JMP will be followed by an address which consists of 2 bytes or 16 bits. It is used for unconditionally jumping to a particular memory location. Then JC, jump on carry to a particular memory location. If the carry flag is sent, Instead of executing the next instruction, it will be going to the instruction which is stored in the memory location just after the JSC. Then J is a jump on 0. Call, it is used for calling a subroutine, or it is used for jumping from one routine or main program to another routine. C is a call on 0. It is a subroutine is called only if 0 flag is set. And the last category is IO and machine control group. These instructions are related with input-output ports, stack and machine control group. The first two instructions in the example, in, out, it is related with input port and output port. It is used for transferring the data from processor to an output device or taking the data from an input device to the processor. Push and pop are related with stack. HLT is machine control. It is used for stopping the program. Next we can see the instruction and data formats. There are various methods to specify the data for an instruction. The data may be specified in the instruction itself. It is the data is a part of the instruction. Immediately after the opcode, the data is coming. The address of the memory location or the input or output device is a part of the instruction, and the data may be in that memory location or IO device. The data can be in the registers. The instruction can be classified on the number of bytes. That is, whenever an instruction is converted into its machine code, all the instruction may not be of the same length. Some instruction require only 1 byte, while others require 2 byte and 3 bytes. Accordingly, there are 1 byte instruction, 2 byte instruction, 3 byte instruction. The operands are in general purpose registers. Then normally it may be 1 byte instruction, and if the operand is specified immediately after the opcode, then it will be 2 byte instruction, and if the address of the memory location is specified in the instruction, then it will be a 3 byte instruction. According to the method used for specifying the data for the instruction, there can be different addressing methods. Direct addressing, register addressing, register indirect addressing, immediate addressing, and implicit addressing. We can see one by one. Direct addressing. In direct addressing, the address of the operand is given in the instruction itself. The instruction format is: first byte will be opcode, second byte lower byte of the address, and third byte is the upper byte of address. The instructions which are using direct addressing may be of 3 byte instruction. For example, STA 2400H. This 2400 is the address where the accumulator content is to be stored. Then in 03. As you already know, the address of the memory location is of 2 byte long, while the address of an input port or output port is only 1 byte long. Therefore, in or out instructions generally are 2 bytes long. First one, the opcode of in or out, then followed by the address of the IO port. Okay. Next category is register addressing. The operands are in the general purpose registers. The instruction format of register addressing are opcode followed by source register, again followed by destination register. But all these three requires only one byte. For example, consider the instruction move A, B. The contents of register B is transferred to register A or the accumulator. The operation code or machine code corresponding to move A, B is 78H. It is 0 1 1 1 1 0 0 0. This 01 is actually the opcode move. Then this 111 denotes register A, the destination register, and this 000 denotes register B, which is the source register. And if it is register C, then it will be 001. Accordingly, move A, C will be move 01. A is 111, C is 001. Then the opcode will be 79. Next category is register indirect addressing. Instead of specifying the address of the operand in the instruction itself, it is specified in a register pair, and that register pair is specified in the instruction. For example, STAXB stores the contents of the accumulator in the memory location specified in register pair BC. And move A, M is coming under the category of register indirect addressing. Move A, M means the contents of the specified memory location is to be moved to the accumulator. The contents of which memory location? That will be specified in the HL register pair. Therefore, before using the instruction move A, M, the memory location address will be loaded into the HL register pair. Next category is immediate addressing. In immediate addressing, the operands are a part of the instruction itself. The instruction consists of 2 bytes, first byte opcode, second byte the data. If the data is an address, it will take 3 bytes. Examples MVI A,05H. The data is 05 and it is loaded into the accumulator. ADI 06. 06 is the data and it is added along with the content of the accumulator, and the result will be there in the accumulator. Then LXIH 2500H. In this case, this 2500 is the address, or sometimes it can be data also. Anyway, since this is loaded into a register pair, it is having 2 bytes as the data. And the last category is implicit addressing, and these instructions operate on the content of the accumulator directly, and this does not require specifying the operands. The operands is specified implicitly in the accumulator. It is a 1 byte instruction. It consists of only opcode. For example, CMA, complement the contents of the accumulator. RAR, rotate the contents of the accumulator. Then RAL, rotate the contents of the accumulator left by 1 bit. RAR, rotate the contents of the accumulator right by 1 bit. And in the next class, we can see the 8085 instructions one by one. Till then, goodbye. Thank you. Thank you, students.